You already talk about metrics? Awesome. Who here has seen the movie Prometheus? I'm sorry. All right, how many of you actually do metrics on your day-to-day stuff? Cool. So those two kind of do come together in a way, because we need to talk about how we actually do metrics. How do we actually do metrics? Now, in talking about those things, how many of you actually think about what you're measuring and why you're measuring it and what it means for your business? Or do you just poke at a very stuff and see if it's good to measure, kind of like the guy did over in Prometheus? Right? I sure hope that's not how you do it. So before we get into this, I want to introduce myself. My name is Rafael Dohms. Now, usually I would just say, yeah, I work at Usability and move on. Today I'm going to give you a slightly longer spiel, but not because I want to hire you. I do want to hire you, but because it's relevant. What I want to talk to you about today is I want to talk to you about really understanding how we do metrics, like really thinking what do we want to measure, why do we need to measure it, and all these little details. In order to do that, I need you to have at least a simple understanding of what we're currently doing at the office, so I can guide you through some examples to really help you understand what I'm talking about. So what Usability does is Usability is a feedback company, right? We allow you to gather feedback from your customers. Sounds simple, right? We started off with a visual feedback tool back 5 years ago where you could just get a snapshot and people could complain about parts of your website. And we grew into different products, so web products, applications. So now you can complain on the web, you can complain about mobile, you can complain about emails you get. It's great, right? It's a unified complaining feedback system. It's great. But what happened is as startups go, we built the first product, and then we decided to build the second product. Now, those two things are feedbacks, right? So you think, oh, okay, cool, you just added some more inputs. No, we created a new code base. Because, we were very pressed for time and all that. And then we created a new product. So then again, you thought, hey, now we added a new code base. So now we had 3 code bases. And by the end of 2016, we had 6 products, 6 code bases. 6 things happened very much similar, but all right, it's a startup, right? We needed to get where we needed to get, and it got us there. But obviously, that comes with a cost. And we started realizing, hey, you know what? This is not working. We need to unify this stuff, and we need to solve this. So what we realized is that the market shifted. The way people look at feedback, and you probably think this is obvious, is we want to look at all of the feedback as one thing. If you're complaining about my stuff on mobile or on the web, I kind of want to understand that whole thing as one. So we started what we call the pipeline project. And the pipeline project, really cool. It's essentially, we're unifying all of the data that we receive. So if a feedback comes in, it's a feedback. I don't care where it's coming from. That's just information about that feedback. But one feedback is feedback. Simple enough. Don't worry too much about the details. But it's really cool the way we did this, right? We're doing a lot of domain-driven design. We're using Kafka as our messaging platform. We're using autonomous microservices, so these messages are bouncing around. And the thing that happens is when you start doing microservices, you start needing metrics because things start getting complex. So what the pipeline does is it receives feedback, processes that data, and spits it out for our users to understand what that data looks like, right? So your graphs, your charts, are your clients happy? Are your clients not happy? So as you're doing that, metrics really become important because microservices are running around. You've now got, instead of one problem, you've got 50 smaller little problems to deal with. And you want to make sure that all of these microservices are running well and what's going on. So what does that mean for metrics? Because metrics are essentially insights into the current state of your application, right? It's for you to understand what is going on with my product right now. Is it running? Is it not running? Are my clients liking it? Are my clients not liking it? What's going on? Is it fast? Is it slow? You need to understand what's going on there. Metrics really help you figure out if your service is healthy. For microservices, anyone doing microservices? A few brave souls, cool. One of the things that you might also use is a canary deploy. So you need to know if a service is healthy to know if you move all your traffic onto it or you don't, or if you bring down a whole cluster, what happens. But metrics will also start telling you what's wrong. Like when your service starts having to handle too many things and you're trying to You know, oh, we need to look at this. We need to go fix this. What's going on? But metrics can also tell you what's right. You still have people coming in. People are using this part of the project more than that part of the project. So these are all important things. But mostly, they can also tell you what will soon be wrong. And this is where it's really important. Not only can you figure out afterwards what happened, but you can start realizing things are starting to go south before they blow up. Right? Metrics can have that ability as long as you have a proper way of observing them. They will tell you, at the very least, where to start looking. Like, oh, wow, it's my database that's blowing up, or my queues are not being processed, or what's going on with that product. So the idea behind this talk comes from the book Site Reliability Engineering from O'Reilly, which is essentially a book written by Google engineers that talk about the day-to-day life in Google. Has anyone read this book? It's a thick book. It's really nice. Has a lot of interesting ideas. So what I pull out of this, and it has a whole section that talks a lot about metrics and understanding metrics. And it brings up three concepts, the concepts of SLIs, SLOs, and SLAs. Right. How many of you have heard of SLAs? Right, that one we all know. SLOs and SLIs. All right, good. You're going to learn something new today. That's cool. Awesome. So what the hell are these? Why am I throwing you the acronyms? So first of all, SLIs. SLIs are service level indicators. These are essentially metrics. This is essentially a quantitative measure of something within your application. Say your response time. Say how many items you have in your database. Say how many people came through your website yesterday. This is something that you can give a number to. Right? Cool, that's easy. All right, so these are your metrics. Then we go on to SLOs. So SLOs are service level objectives. That is the target that you're trying to aim for, right? So let's say you want your response time to be less than 200 milliseconds, or you want it to be lower than 500 milliseconds, or you need to have 10 active users on a day. All right, these are targets that you're trying to achieve. Now that sounds easy, and that's good, but it's also very important. Because this is not only telling you about the performance of your website or about how you want things to work, it can also give you insights into your architecture. For example, taking an example from the pipeline, SLOs can actually help you drive your architectural decisions. So we started creating this new pipeline, and we talked to product, and we figured out that our SLO was 150 milliseconds. And I'll tell you the story of how we got there in a little bit. But let's say we have this SLO of our site needs to respond in less than 150 milliseconds. I mean, no biggie, simple enough. We were migrating from Symfony into our stack of Chimera PHP and Zend Expressive, which were essentially a micro framework with a very thin CQRS layer on top. So we implemented that, and we checked our SLO. Just by implementing that new framework, we actually had a 95th percentile average of our response time down to 5 milliseconds. I know, cool, 5 milliseconds is a lot less than 150 milliseconds, so the math is good. And that gave us the opportunity to say, you know what? We don't have to try and optimize this thing any better. We can now go spend time in the other stuff that's valuable within our product. So instead of trying to optimize your code, replace all your echoes with prints or prints and echoes or whatever the hell you do to optimize the code, we actually had the time to go invest in other places. So we were able to go down into looking into our domain model and trying to figure out how else we could do the business better. But it gave us the opportunity to think, where do we as developers need or want to invest time? And that's the thing about a good SLO. It will help you make these decisions. But I'll get you more details on that coming up. Then finally, we have service level agreements, which you're all familiar with, and this is where the money is, right? This is essentially where you tell your clients, I guarantee that we're going to hit this SLO, right? So once you say your target is 150 milliseconds, this is where you say what happens if you miss those 150 milliseconds, which is not good, right? So this is where you say, hey, we guarantee this much service, and these are the legal consequences of not hitting those targets. Cool. All right. SLIs, SLOs, SLAs. So let's go by parts. If you want to do metrics, the first thing you want to do, obviously, you want to measure stuff. Now, a couple of years ago, Etsy put out a blog post. How many of you know Etsy? All right, cool. So Etsy is this huge company, right? Rasmus works there, lots of cool people work there. They must be doing something right. So they put up a blog post, and they said, they were talking about how they do monitoring, how they do metrics. Essentially, they said, yeah, okay, if it moves, we track it. Now think about how big Etsy is. Think about how many things are moving in there. That's a lot of stuff. So okay, let's use that as a parameter, and let's start. Metrics, actually, they fall into two categories. We've got telemetry, things that tell you about your business right now. And we've got statistics, things that tell you about patterns that you've seen over time in your application. So if anyone is a fan of Formula One, I mean, you know telemetry, right? Telemetry is, in Formula One cars, each Formula One car can actually give you details about the temperature of the left wheel, the pressure of the tire, and how quickly they did a turn. Now, this is so much information you get from this car while it's going around in this track that actually the engineer in the back in line in the garage can actually tell the driver, hey, if you turn your wheels this much more on that curve, you'll get 5 seconds more in a, well, 5 seconds is too much, but 5 milliseconds at least. And that's a really powerful tool, right? To be able to remotely look at something and analyze so much, have so much valuable information that you can give someone an advantage while they're actually running on the track. I mean, think of that as your product, right? Think of this as, your website is there running, and, users are coming. And as users are coming, you're able to say, here, we need to increment the cache in this thing here to get us the right performance. It's a lot of information. So much so that it's actually forbidden in Formula One for the engineers to give tips to the drivers because it was getting completely insane. Good call. Right? So that's telemetry, right? Really knowing, really focusing about what's going on right now and what do I need to know about my business, what do I need to know about my product at that point. On the other hand, we have statistical data, which is where you look back over the years and try to understand patterns. Oh, on Sundays, I have more users. On Sundays, things are faster, or whatever. Same thing, if we keep up with the Formula One idea, this is when I can go back and check, yeah, okay, who won last year? Or when was the last time a Brazilian won? And oh my God, it's been so long. It's cool. So, any Hamilton fans out there? Okay, good, no. Great. That's good because I'm not a fan as well. But that statistical data is also very important, right? It gives you the ability to understand over time what's going on with your product. And usually if you talk to your product owners, if you talk to business, this data is also really important to them because it allows them to make better choices, both as business and you as architects. Cool. So give you an example. We looked at a pipeline and a couple of examples of metrics we found. For telemetry, really we want to focus on the response time of our endpoints. We have one public endpoint where feedback items come in. And we want that to respond really quick because that is the direct user experience that your end users have with our product. Right? So if you put our button on the website to collect feedback and your customers are clicking the button and it takes forever for them to get a reply, they're going to complain more about your website. So we need to make sure that our stuff is really quick. So that's telemetry. We keep an eye on the response time of that endpoint and do whatever we need to make sure that that endpoint is responding as quickly as it can. On the other hand, if we look at statistical data, understanding what is coming in, right? Feedback item comes over many channels. We want to understand, hey, our web channel is way more popular than the mobile channel. Or if you look at it differently, people on the web complain a lot more than people on mobile. Happens, it's good. So understanding that also helps product drive decisions. Which product do we invest in? How do we invest in that product? What does it need? Why is it that we get different metrics? Is it just different types of people? So example of statistical data right there. Now let's go back to what Etsy said. If it moves, we track it. That's a lot of stuff because you can track the system throughput, you can track availability, request latency, the error rates of your app, but you can also track the CPU, the memory, your peak frequency, incoming data, bandwidth, and then if it's not enough, you can also measure the measuring tools you're using to make sure that they're measuring the measurements. It's a lot of metrics. It's a lot of stuff to measure. It's a lot of information. Now, if you work in the feedback industry, or if you're a human, you will figure out something. The more information you throw at people, the less they understand it. Right? If I stand here and I keep reading these things at the speed I just read this, everyone will be half asleep. I mean, half of you already are asleep, but that's fine. But it's too much information, right? Humans are not made to consume information, like Twitter. Although apparently for Twitter we managed to do it. I don't know why. So we need to figure out what is relevant amongst all that information. So if we think about all the metrics that our system has, only a few of those do we consider are actually SLIs. I mean, you want to have all those metrics. You want to make sure that somewhere in your system you're able to get to those metrics because maybe at some moment you will actually need them. But all of these metrics are usually what we call auto-collected metrics. If you use something like Prometheus, there's a bunch of exporters for like PHP FPM, Nginx, and all these other things that just give you all the information. How many requests per second, what's going on in your server, memory, CPU, Kubernetes has an exporter, containers have an exporter, exporters have exporters. I don't know. There's lots of stuff. But you also need to care about your application metrics because that's the one that touches your business, right? At least as developers, it's where we're going to be working. So SLIs shouldn't be all of your metrics. They should be a subset of those. And you need to pick really good ones. Now, here's a bit of how to pick those. SLIs actually change according to who is looking at SLIs. So if I take someone from development and I ask them, okay, what is more important about this product to you? You'll tell me a couple of things. If I go talk to product, they're going to be, well, what are the users thinking? Okay, cool, that's what the users are thinking. Maybe if you go talk to someone in your ops department, they're going to go, oh, all I care about are containers. I don't care about your code. I care about containers, right? So depending who's looking at it, different metrics will be SLIs and different SLOs will be set per department, per group, per team, per role. So you need to understand all of those. Then you need to understand the nature of your system. What is it that you actually do with your system and what can be relevant based on that? If you have a user-facing system, then maybe you care more about its availability, the throughput. Can it handle all of the incoming requests? Is it responding within time? Because users, humans, we complain a lot if things are slow. We feel that difference, right? So you want to make sure latency is something good. On the other hand, if you have a storage system, eventual consistency. I don't care if it takes 5 minutes to store this thing, but I now do care a lot about durability, because if I store data and it's not there, then it's not a database, or a very bad one at that. So depending on that nature, you want to think of other things. Big data systems, right? You care about the throughput. You care about the end-to-end bins, like big pipelines, lots of data coming in. You want to make sure it's going through the system and it's not getting hung up somewhere. So we looked at what we had in terms of the pipeline, and we identified that we had two factors. We had a user-facing system, which is the endpoint that collects the data where we talk to those users. But we also have the big data aspect, because we're receiving feedback from all of the customers. So you can imagine that that's a lot of people complaining, so you get a lot of feedback items. There's also good stuff in there. I'm only talking about the complaining ones, because that's the ones that stick with you. But we also have that aspect of lots of data that needs to be consumed. So we looked at it, and we came up with a couple of SLIs that were important for us, as well as for the product owner within our team. So the response time of the receive endpoint, like how do we respond to users? The turnaround time, so what happens between receiving a feedback item and actually showing it in our backend to our customer. The time it took for each of the steps we do to a feedback item, right? So it comes in, we have to do a bunch of stuff to it before it's ready. How long does each of these things take? Where do we need to make it faster? And then also, how many feedback items are coming in? These are all things that seem relevant, right? If you're receiving feedback, these will tell you, are the end users happy? Is your system being used? It'll tell you how long it's taking for your clients to finally get their data. So these are all very important things. Now, if you turn over to the product team or to the ops team, they were like, no, all I care about is your node, your Nginx FPM metrics. I want to know CPU memory. I want to know if the containers are not blowing up. I want to know if our cluster doesn't have 50,000 machines, because we can pay for all of those. That's what's important for ops. But it's important to understand that. And it's important to embrace that. So depending on the team, you're going to have these different metrics. So think a lot about what is the perspective of how you're looking at these things. Cool. Once you have metrics, once you're now able to measure them, you know what you're measuring, you understand what they mean to the business, you need to pick where should they be. Because if I tell you, look, your response time is a 5. 5 is good? Is 5 bad? If I tell you, yeah, there's 2 bottles of water on the table. Okay, there's 2. Should there be 3? Should there be 1? Is that good? Is it not? So you need to pick the targets to tell you how to interpret your metrics. Now, picking a target is simple. Either it's a fixed value, it needs to be lower than this, higher than that, or it needs to be lower than this and higher than that. You just pick that window of where it's relevant. And that depends on a lot of what the metric is. If it's response time, you can talk about the percentile. So I want 95% of my requests to be under this much. I want 99%. And you can pick for availability, how many 9s do you want in your percentage of uptime? The important thing is you don't pick those based on what you have now. Because we work a lot with refactoring, right? We work a lot with recreating systems in better ways. And if you judge yourself always by the old system, you're probably not getting all the information there. So really try and focus on what you're building and who you're building it for. Right? Instead of just taking for granted, oh, yeah, it's going to be 2. Why? Oh, because the old one was 2. Well, maybe the new one should be 1, not 2. So start looking at that. What is the user experience? What is the business value that you're delivering with that feature? If I'm delivering this endpoint for feedback to come in, what is the experience that we're trying to build for those users? Is it okay if we do 150 milliseconds? Does it make a difference? Ask yourself those questions. So we did, and we were looking at this endpoint and trying to figure out how do we measure the speed of this endpoint, or where do we want it to be? And then we came up to the product owner and said, hey, PO, what should be the response time of the endpoint that receives the feedback item with the /rest post thing? And they were like, what? What? So first of all, pick your language, right? You're talking to product, talk ubiquitous language, talk business value. So we said, okay, well, never mind, hold on. How long should it take between a user clicking a button and getting confirmation that we have their information? Oh, yeah, that it should be really quick, right? So we actually did that. So we asked this question within our company, and we got a bunch of answers. Some people said immediately. Some people said we sell it as if it's real time. Guess which department that was, right? Another one said, hey, 500 milliseconds because we got all these other complications and the HTML and this thing. How many of you were in Matt's talk this morning? The Dungeons and Dragons? Yeah, that was our resident wizard. He just knew too much about the system. And then finally we said, I don't know. Okay. Some people maybe just don't know. But now we had all that information. Now we had different perspectives from the different departments of the company. We talked to sales, we talked to customer success, we talked to product, we talked to the engineers. We had a view on what the company was trying to do. Hey, if we're selling the thing as real time, then hey, maybe we should aim at something that sounds like real time as opposed to dealing with delayed responses. Or at least we should tell sales not to do that. Oh, it's a good idea, doesn't always work, but at least now you have that feeling. You understand what's going on with the company. So we went around, looked at all these things, figured out that the perception of a human that something is immediate is about 100 milliseconds. Most APIs out there will do about 180 milliseconds on average. So we aimed at 150, right? It's a little bit more than immediate and a little bit less than the standard, and something that we thought we could achieve. Checked all the boxes. Right? So now we have a concrete idea of just how much time we need to invest into the performance of this endpoint. When we start hitting those points, yeah, it's okay. You don't need to optimize it further. Very important with SLIs, you need to have, with SLOs, you need to have some, but not many. Thing is, if you have every SLI or everything has an SLO, then you need to keep track of all these things. You're now trying to, juggle all of those eggs at the same time, and that's maybe not the best idea. So figure out if that SLO is important as well to you. Every SLO, like I said in the beginning, it should help you settle an argument. If you're discussing with product that you want more time because you want to optimize this code and it's already running like 50 times faster than it should, then maybe you don't need to spend more time making it perfect. Oh no, but we need to fix this because object calisthenics. It's a good thing to do, but sometimes you don't need it, right? So the SLOs can also help you figure out where to invest more time or not. We don't need everything to be perfect. We need everything to be within what we expect it to be. And don't overachieve. Now that sounds weird. Why am I telling people not to overachieve? That should be the difference. That's what 10x engineers do, right? We achieve and then we go better. So it's an interesting story that actually comes from Google. Within the Google platform, there's a system called Chubby. And it's a very crucial system to the internals of their work, meaning that a lot of the systems use it to do stuff, right? So I'm not exactly sure what the role is, but imagine something like authentication or something. Everything has to end up going through there. Now, they had a really high SLO of uptime, 9 and all those 9s and lots of 9s in the number, and they were hitting that, and it was great. And everyone was using that system, and everyone was coding on top of that system, and things were beautiful. Until one day, Chubby went down. So their systems now no longer had Chubby to talk to. And what happened? Everything else stayed up because everyone coded thinking that Chubby would obviously never, crash one day. Yeah, no, that's not it, right? Everyone started getting used to the fact that Chubby just didn't have downtime, so no one coded fallbacks around their stuff. It's like, no, S3 is never going to go down, right? Yeah, that was 2 years back. It was such a great experience. So everyone was relying so much that they were so much overachieving that SLO. It's like, oh, I don't need to code a fallback here. Chubby will always be there until the day Chubby was not. So what they learned from that is actually what they did is they took their SLO and turned it down to 5 9s, right? So 99,999. Because that was just enough for the business to be happy, but enough for other developers relying on Chubby to think, hey, you know what? This thing might go down. We need to do some fallbacks. And what they actually do is if they start overachieving that SLO in a month, they'll bring down the service for a couple of seconds and bring it back up to be able to stay within that SLO. I mean, that sounds mind-boggling, but on the other hand, if you think about how us, developers do things, yeah, it kind of makes sense, right? We tend to not think about the things that never go wrong, right? And the things that never go wrong, guess what? They always do go wrong eventually on a Friday night when you're trying to take off to a conference. So that was interesting. Don't overachieve your SLOs. But also make sure you are adapting to the changes, right? Like I said, Usability was built in one way, which was great for the first 5 years of its existence. But down the line, the market changed. How users use your stuff changes. How people view your products changes. So evolve with that. React to those changes by keeping up with that pace. Make sure your SLOs are not static things that you put up on the wall and they're going to be great one day, but keep track of those. Hey, maybe now we refactor the system. Let's reevaluate those SLOs. Cool. And then finally, we have SLAs, where we need to meet expectations. Now, this is where you put consequences to your objectives. This is usually not a thing where developers are involved, right? We can give them instructions, we can help, but at the end of the day, you want your lawyer to be looking at this, because this has consequences for your business. Unless you are the head of your business, in which point, congratulations, you now have 2 roles and you have to deal with that. But if it's not, if you're just a developer within the company, make sure that everyone who's making this decision has the information, but take a lawyer with you because they know exactly what you should and shouldn't promise, hopefully, if they're good lawyers, right? But it's very, very important to have that information. The other thing that you can do, though, is to make sure there are safety margins in place. So if the SLA says you need to hit the 99th percentile at 150 milliseconds, then put your SLO at the 999th percentile within 150 milliseconds. Because if you start blowing up your SLO, you still have time to fix it before you start blowing up your SLA. Because that's where the money is, and that's where You're going to have lots of meeting afterwards, and we all know we don't like to sit in meetings. So give yourself time to react to those changes and fix that. Cool. So let's go into a bit of practice. How many of you using Prometheus? A couple of you. Influx? Maybe Google Analytics? Something else to do metrics in general? Like, what is it? Graphite and StatsD? Cool. So, right, so since I promised you Prometheus and not just the movie references, I want to talk to you about Prometheus. What is the difference with Prometheus? Why is Prometheus actually pretty awesome? So if you've done metrics in the past, especially the ones using things like Influx, what you usually have is you have your application, it collects data, and then it pushes that data into a central repository of statistics. Meaning that if your application starts growing, you need to make sure that that thing is not falling over or you're losing metrics, right? So you need to scale your Influx, your StatsD or whatever with the amount of traffic that you're doing. Now there's plenty of ways of doing that. It's not the most complex thing in the world, but it is something you need to be aware of. The difference with what Prometheus does, instead of using this push model, it uses a pull model. So what you do is you store data locally in whatever you want, APC, Redis, or some other in-memory thing. And every now and then, Prometheus comes and says, hey, give me the data. And takes it over and crunches the numbers, figures out, oh, I read this, I haven't read that, and stores it into their data. It means that this thing doesn't have to scale. The only thing that you need to do is that every time you scale up your local storage with, which is a lot simple. If you think about Docker Compose and Kubernetes, all of this stuff kind of goes together in here. And this is a completely different system you don't have to worry about. Sounds oversimplified, but that's the idea. Thing is, Prometheus is really good for telemetry data because it's really good at acquiring that data and just pushing that data out, crunching the numbers, and giving you statistics. It is not, however, too great at statistical data because it is not built for long-term storage. It's really built for a lot of the telemetry stuff. You can do it. You can add a data retention of a month, a year, whatever you want, and it will crunch the numbers for you. But it's like we said in the Go talk. If everything you have if the only thing you have is a hammer, everything starts looking like a nail. Prometheus is one of those things. It's great for that, but maybe not the greatest tool if you want to do long-term data analysis. However, it has a bunch of plugins where it can automatically take its data and push it out into things like Influx, for example, or whatever else you want to use. Which means you can have that beautiful, Ferrari of a statistical server giving you all the telemetry, but you can also have your stable backend with all the historical data so you can do more detailed analysis of the patterns, which works great. It'll give you a couple of options. You can either use a counter, which is simple. It's one number, goes up. That's it. You can add labels to it, so you can say, hey, I just counted one request for this URL with this HTTP code. But that's it. It's a counter. It can only go up. You can also use histograms. Now, histograms are more time series, right? So this is how long it took, and data gets stored in little buckets. Oh, these are how many requests were from 0 to 1, how many were from 1 to 2, or whatever. Gauge is weird. I keep butchering words in stage, it's great. A gauge is essentially a counter that can go up and down, right? Because it's not a stable number that always increases. So think about number of items in your database. It doesn't always go up. It sometimes goes down because you deleted things. So a gauge is really good for you to measure that. And then you have a summary, which you'll probably see less use out there, which is essentially a histogram, but it automatically calculates some of the percentile numbers for you already. Whereas the histogram gives you all the data, and then you have to use the Prometheus query language to calculate the percentiles. The summary kind of gives you that straight out, so it's a lot more efficient at doing that if that's all you care about. But you'll see very little use of it in general. At least I haven't found that much of a useful scenario to use that. So if you're doing PHP, this is the library I've been using, Jimdo. It's not the best library in the world. It's not the worst library in the world. It could use a couple more interfaces and some improvements in default configuration and some of the classes in there. But it does the job pretty well, right? So in a regular day, what you would need to do in order to implement metrics in your code with Prometheus is you have your code. In your code, you'll add the actual calls to the code that does this. It will store the information locally on APC. And then you'll also make available the metrics endpoint. And that's the important thing, is like Prometheus is going to come to your application, and in order for it to do that, it needs to figure out where that point is. That's usually the metrics endpoint. It'll come in there, and in there you'll essentially take all the data from the local storage and output it as a text format. Now, the beautiful thing is that the library handles all of this for you. All you have to do is actually increment the count, and you're good. So, let's talk about code, right? Can you read it better here? So this is a simple example of using that library in your code. Let's just dive into it. So first thing you're going to do is create an adapter. Adapter is your storage. This is where all the data is going to be. It's what they call a registry. It can be either APC or it can be Redis. Now, you need to think about that depending on what your use case is. If you're measuring simply from your web application, APC is probably fine because it's shared by the FPM, so that data doesn't go anywhere. If you're trying to read metrics from a command line execution command, or let's say a long-running process or a cron job, don't do APC, because it just so happens that APC dies with your command, so there will be nowhere to read it from, right? So if you're doing CLI, don't use APC, use something like Redis. Then you have a whole new can of worms to explore, which is great. But once you have that registry defined, you can start creating your actual metrics. So in this case here, we're creating a histogram. So a histogram, again, series data. First thing we tell it is here, this is the registry you're going to store stuff in. Then we give it a namespace, which is my application. So this is the application that you're actually measuring. Then you give it a name of that metric, in this case, response time milliseconds. Now, the convention here is to make the last part of that name the unit you're measuring in. So if you're measuring seconds, milliseconds, nanoseconds, whatever, put that in, because it's easier for someone who's reading this on the Prometheus ends, right? As you're looking for your counters, you don't want to keep remembering, is this microseconds, is this milliseconds, what is this, right? So think about that. Then you have a help text, which is this, essentially you explain what the metric does. Also good for someone reading that information outside of your application. Then you create the label names, right? So like I said, every time you count something or you measure something, you can add labels. So I can say, every time I get a request, I want to register the response time of that request, but I also want to know, oh, I just measured 5 seconds, but what URL was it? What HTTP code we got, right? So this is what we're passing it here, the status code and the URL. And then finally, we have the bucket. So the bucket is essentially how it stores information. So instead of storing this URL took 5 milliseconds, what it stores is, oh, this was more than 5 milliseconds less. So it falls into the first bucket, the second bucket, the third bucket, the fourth bucket. If it's more than 50 milliseconds, then it falls into the 50 bucket and the 100 bucket. All right? Cool. Then you just measure and observe that measure. So here, it took 15 milliseconds, and the HTTP status was 200, and the path was URL, which is great. Cool. If you want to do the same thing with a counter, again, adapter, namespace, name, help, and then the labels. You don't need buckets. Again, this is a counter. Number is just going up. It's fine. And then you can increment either by 1, passing the values of the labels that you give, or increment by a bunch and do the same. Right? Cool. So that's what you would do within your application. This is what you would do within your handlers, within your controllers, whatever it is you have. Then you need to have that endpoint where the application can come, where Prometheus can come in and get that information. That's also pretty quick and easy with the library. Again, you focus on getting an adapter. Then you create a renderer, which will take all the data from your local storage, convert it into easy to read text format, and output it. So if you do that for the example I just showed you, you will get something like this. And you can really observe here those things that we said. where the help text is for that metric, what kind of metric it is. In the first one here, we can see it's a counter, and we can see where we measured for the status 200 and /URL, we counted it 6 times, right? Because I called 2 increments there. And for the response times here, again, we can see that for that response time of 15, we actually have all of these buckets showing us that something fell into those buckets. But since it was 15, it doesn't fall into the first 2 because it was higher than that, right? And then you also have the count and the sum at the end, which you can use to do other types of statistics with. But like how many times that was called, how many calls, or whatever. Cool. So there was a demo. I only have 5 minutes left. So actually, this code replaces that demo. It's not really too much to see. But the idea is, if you go to this repo, it has 2 containers, the Prometheus container and the application, which has exactly the code I just showed you running. You can then switch over and see a bit of the Prometheus graphing interface. And I'll be bold enough to go into that one at least to show you. If this works right here. Right. Ooh. There we go. So this is the graphing interface that comes with Prometheus. Once you run that container, all the instructions are in there. You can here choose the metrics that we have used. So for example here, if I just want to see the total of that metric and graph it out, I can see here, it's going to group it by the URL and the status. So I can see here that the green line here was 200 for the URL metrics. So here's how many calls I've gotten to that endpoint. And then I can play around with it because I can also start filtering. And I can say, you know what? I only want the ones with status 500, and I want to see how that's going. And, oh, OK, I've got a bunch of errors. Maybe I should try and fix those, right? I'm not going to go into the query language. It's a whole talk in itself. Or setting up Prometheus, it's a whole other talk in itself. But this gives you an idea of how you can work with it. And if I switch back to Keynote, that's not Keynote. That's Keynote. There we go. Puppy for you. All right, cool. But the repo has all of that to you. Very important. You can't act if you don't have, if you can't see those metrics. Otherwise, they're just numbers. Like I said, 2 bottles. What does that mean? But you really want to visualize. So this is an example of what we did with that data. We use Grafana. Grafana hooks up beautifully to Prometheus. And this shows us requests per minute, how many are coming in, which endpoints, which statuses we're getting on it. This shows us the average response time for those URLs as well. And down here, we calculate the 99th percentile, the 95th, 99th, and 999th percentile for those same URLs. So you can divide it by URL. You can say, OK, just give me it for all the URLs. And here we only have 1 endpoint, so that's easy. But you really want to keep an eye on these things. And this is our error rate. It was great. It was 0. I love it. But it shows us how many we actually have, how many errors, 500s and things like that we actually have running per minute. Cool. We also have this, which is my personal favorite to stare at all day. This is actually the statistics of feedback items coming in. Now, this is a semi-production state, so we actually got a higher average in our production servers. But here we can see, we can actually tell, look, 75% of all the data comes from this channel, which is our web campaign channel where we do surveys, as opposed to that great thing we needed to put live, which was the product whatever. It's actually not really that used, right? So this actually tells product, look, we invested all of that time into this one instead of refactoring this one, and it only represents 5% of our business. Is it worth it, right? So here you can see the per minute. You can see the graph of it coming in, and then it's divided per each of these channels, per each of our products, like I said. So this information can really help you make decisions, but it can also tell you, oh, why do we have a spike now? What's going on? Maybe a client started rolling out the campaign, or maybe we need to scale up our service. This is actually really good information to automate all of your scaling and things like that. So monitoring is really good for those aspects. But metrics without accountability are just numbers on a screen. So make sure you actually know what these numbers mean. Make sure that you know what to do when those numbers go bad. So, hey, this number is great. It's turning red. maybe you should do something about it, right? But really understand what they are. So act as soon as possible. As soon as you see an SLO being threatened, as soon as you see something is happening, understand why. That's what we do all day. We look at our code and we try to understand what the hell is it doing. Why is it going bad? What did we do? Did we maybe forget to do something? So keep them safe. The SLOs depend on us. Let's pretend this is a quest, like in the first talk, and go after it. And keep an eye on that. But really understand, before you start measuring everything and putting metrics everywhere, really try to understand which of these metrics are really important to you. Thank you very much. So I work for a feedback company, which means I really like feedback. So please give me feedback on Joined In, on the conference Joined In page. You can also use this link, which goes to a usability form as well, which I put up so I can get more detailed information in case you want to give me more detailed feedback and see this whole pipeline actually processing stuff. We are hiring. If you want to get away from all this Brexit stuff, we're looking for back-end, front-end, ops, anything. If you want to work with us, we have a really good, nice environment, beautiful office, beautiful people. So come talk to me afterwards if you want to hear more. Does anyone have any questions? No questions. There's a question.
Hi. Super useful talk, thanks.
Thank you.
You showed a demo of or an example of histograms, but you used bucketing. Is there a way to do it without bucketing, so you can like arbitrarily save like, oh, that took 102 milliseconds as opposed to 100?
As far as I know in Prometheus, and I'm not the world's expert, no. Because that's their business definition of what they want to measure is with buckets. I have not tried not adding any buckets. So I would have to get back to you on it. It might be that there is a technicality in there that can happen, but I haven't really explored without the buckets.
Got time for one more question. Any more questions?
So thanks for the talk. You talk about like action after, like if there's something going wrong or something. Do you have in place, or does Prometheus support something that allows you, I don't know, scaling or auto-scaling, or I don't know?
Okay.
Like
the one thing that it has that is really useful in this case is you can also set up alerting. So at the very least, you get more than just a red number on the screen. It can, trigger different calls. On its own, it doesn't have anything to necessarily auto-scale something. But these are all metrics that are all readable through APIs and different integrations. So you can use it, for example, to power your AWS scale-up decisions and stuff like that. So it's just data to be used for those, but it doesn't necessarily have any tooling to do that. Not that I have explored, at least. It goes to say that I am not the one keeping up Prometheus. I'm the one making sure we're putting data into it. We have an entire ops team dedicated to our infrastructure layer, and they are the ones who really know about the inner workings of Prometheus, which I kept away from here. But there's a great talk from DPC, was it DPC? Where someone went over this, and I'll get you that link if you want afterwards, which talks a lot more in detail about the Prometheus stuff.
Thank you.
No problem.
We still have time for one more question. Okay, right at the back.
Going once, going twice. Sold.
Well, I'd just like to say again, great talk, thank you.
Thank you.
And this is just more for yourself because you clearly got experience with metrics and analysis. What would be one of the gotchas with choosing metrics, and maybe give an example of a dumb metric you've seen people obsessing over, if you have any anecdotes like that?
All right, okay, let me put me on the spot. I mean, the usual stuff is easy, right? Measuring response time, and actually response time is one of the interesting ones, because we have the tendency, like Kat said, to use PHP for everything. And the thing is, if you measure response time within PHP like I did here, you're not measuring response time. You're measuring PHP processing time, because you're missing all of that Nginx layer and all that, right? So that's one of the things we kind of started like, oh, this is great, and look at our, whoa, we're measuring the wrong thing. right? So it's something interesting to keep an eye on. Nginx actually has a great exporter plugin. You drop that in, and it actually gives you the same thing. Response times with the URL, HTTP status, and the method, whether it's get, post, or whatever. So that's a good tip. Start there first with the response time, but focus PHP more if you're really understanding those businesses. I wish I had any failures that we had in the past, but all of this is still pretty new. We're slowly going to production. So ask me again in a year, and I'll probably tell you all the wrong things we did. We did have a moment where we had 2 separate metrics, and then we created another one and realized it's the same thing. Why are we measuring it twice? So keep an eye on that. Make sure that, if you have a project that's large enough that both ends of it are actually communicating when you do metrics, because you may be measuring the same things over and over again. So that's just a quick tip. Whiskey time, I guess?
Yeah, no.
Cool. All right. Have a great rest of the conference,
Thank
people.
you too, Rafael.